I'd like to talk today about Asphericon and Asphericon space solutions. It means Asphericon, first of all, is an optics manufacturer, and we have some visions that we would like to bring to life. So our company was founded in 20 years ago, roundabout, and we have the mission to democratize light. It means we need to build lenses and optical systems that are able to be used for almost anybody. And this is our vision and mission, and we would like to bring them to life. For this, we have a full circle of, from the customer idea towards all the design work, towards manufacturing, and back to the customer with a solution that he likes and that will support him in any kind of optical system. And all this is based on our Asphericon internal cloud, which means we have a physical based server in Germany and in Czech Republic that collects all our data, and we have all the data available for 20 years. Every lens that is manufactured at Asphericon is captured and stored in Asphericon, and we know what we do. So we have traceability, we have cyber security, because everything is based in Germany and nothing is in a virtual cloud, let's say. And yeah, so to continue, we are not only a company that prepares optics, but we also have kind of a mission to include new technology into our production system, not only via improving the software or improving the interface, but we are also using artificial intelligence and VR to onboard our new colleagues. We had created the environment of our production, the machines, the tools, and how to handle it. And this is what we do. So we implement new technology into our machine learning, and we, we implement those new technologies into our system to help the new guys to onboard quickly. You've seen this kind of parts before, but I want to go into details later on. So for space, it's important to get high quality optics and with the lowest roughness, and all these points for lenses are important to get a strong performance. We have a lot of materials that we process, from glass to Ceradure, silicon fused silica, all glasses that you can imagine. Some are not because they are poisonous, but yeah, we have design, and everything is important for satisfying the customer. I will come to some examples, what we contributed. So for example, we contributed those lenses that you see on the right-hand side. One of it, the yellowish ones, is the largest sphere made from calcium fluoride that flies in the space right now, or is going to fly. I'm not quite sure. It's about 100 millimeter in diameter, and all the other lenses were manufactured in Germany at Asphericon. We developed a new polishing process, which is called angstrom polishing, to achieve roughnesses lower than 1 nanometer for a sphere. And A-spheres are possible to achieve these roughness as well. The satellite Sentinel-4 operates in a geo-orbit, and it seems like optics for this satellite is a very small and minor contribution, but imagine, without these lenses, you cannot build the spectroscopy device, and therefore you cannot have the mission. So it seems like it's a small contribution, but it's actually a big one to develop also those techniques. And yeah, so climate change combating is possible with the Asphericon lenses. Similar project is Sentinel-5, where we have different varieties of materials, like fused silica, silicon and zinc sulfide. And Zero-Dur was ground support equipment for this mission, which means we also performed lenses or freeforms, what I come later to, with special shapes, which mean they have you can see at our booth, the one I mean, they have different radius in different directions. So if you wanted to see it, just step at our booth and just see what we did for Sentinel-5 ground support. Here again we achieved less than 1 fringe of irregularity and less than 1 nanometers on on spheres, I'm sorry. And we cut the optics due to weight reduction issues. This is a quite new satellite project or lens project, which means it launched like 2 or 3 weeks ago, and it's for monitoring Arctic Sea for the Norwegian military base. And we did perform the lens manufacturing, not the coating, because we were not qualified yet for these processes, but we will do. So we have currently a silver coating available for defense applications right now, but we will for sure qualify them for space. And here we used MRF to achieve RMSI values less than 15 nanometers on a very relatively large lens, which means they are kind of around about 150 millimeters. And there's 15 nanometers with the MRF technique is at the edge of what is measurable, actually. So we are not limited by the polishing, but by the measurement devices that we are able to have. Okay, what's next? Yeah, and without positioning of the satellites, we cannot work. So we developed a star tracker together with Therma. Therma does the assembly. Asphericon creates the lenses, and the assembly is done at Therma, but we improved the design of the lenses and of the system. So without these star trackers, it's not possible to use the satellites that are flying. Yeah. And last but not least, I just mentioned the freeforms. This is the future of space, in our opinion. So freeforms are able to reduce size, field of view improvement, and the third one I just forgot. It's 3 things: space, increase, and decrease the number of optics. So on the left-hand side, you see so-called sugar cube, which means it works with internal reflection and is for an infrared sensor, detector and sensor. So the incoming light comes from one direction, it makes 3 or 4 times the internal reflection, and then it goes out to the sensor. And this one is really great because you can plug and play. If you have a really good mechanical inlay or outlay, then you can plug it in and you don't have to adjust 5 or 4 lenses. So every precision is made in the manufacturing process, not in the assembly process, which means you plug and play. That's our goal, to develop optics that democratize light so that everybody can use it, and you don't need any physics studies behind it to use it, but you can just use it, simplifying the light and the use of light. And with this, I don't know, I finished? Okay, 5 more minutes, but I think you have a little overview what Asphericon does and what we are aiming for, or what we are looking for, is partners that need optics and optical systems and consulting in optical systems. And yeah, if you have any questions, we are right there at booth 17. And if you want to see the small little ground support equipment from Sentinel-5, you're welcome to join our booth. And yeah, thanks. Any questions? So the size, the size of the.
I was just wondering what is the hard part of making those sort of integrated optical systems?
The hard part.
Why is it difficult?
It's good. To reduce the roughness and the surface form accuracies, you need a lot of experience and knowledge, and also what I said, the software, the cloud behind the Asphericon. This is the sophisticated system that we always improve through programming and through artificial intelligence. And the hard part is to match the machine with it's not matching, but to receive results that are within the range and can be measured, because there's measurement tools. It's very hard to achieve, let's say, RMSI is less than 0.3, 0.4 fringes, which is, yeah. So the edge is not the polishing, it's the measurement actually. And for the freeforms, if you like to know, there you need reference surfaces, and to reference them, it's really hard to measure them, to detect those references, so that you can really put the lenses, let's say the surfaces, on the right spot. So you need the references set very, very tough and strict. And then if you have the references, you can polish the surfaces, and then you have the plug-and-play system. But thanks for your contribution.